Hello, and welcome to a very special 8-minute demo video series. Today, we're going through a video tutorial on OIS 6.3 Advanced Workflow Design and Best Practice Video Shorts. Yep, these are going to be smaller videos on specific topics. And the topic we're going to talk about right now is everybody's favorite, looping. Alright, we're going to take a loop at looping now. And there's two types of looping, object level looping and policy level looping. And there's two options really for policy level looping that I'll be covering. Because of the complexity of this topic, I have policies already worked up for this, and I'll just review what they do and then go through the steps of creating them, and then I'll run them. Alright, so object level looping. It's exactly what it sounds like. It's looping at an object level. And you might ask yourself, why would you want to do this? Well, there's a couple of reasons. One, maybe retries. Maybe you're trying to restart a service and you want, if it fails the first time, but you know it will happen the second time, then you could loop. What else? You might want to loop and wait on something, like you're reading a line in a file for a specific value, and you're not going to continue until you do, or until it tries 10 times and then you fail out. And that's basically what you see here in this use case. So any object can have looping on it, whether it makes sense or not. And the way to get to the looping menu, you can't get there from properties. There's no tab there. So if you right click on the object and go to looping, these are the looping properties for this particular object. When you first come in here, it looks kind of like this, but we want to enable looping and then give it a delay between attempts. I believe that was 2 seconds in the previous example. And this is the number of seconds, not minutes or anything like that. So the delay attempts is in seconds, and I'm going to put 2 there. The bigger the number you put there, the more delay between attempts. So if you are basing your exit on the number of attempts, the longer the entire loop process will take if it goes through all the attempts. Now there's exit and do not exit. These are very similar to the include exclude for the complex link logic that we talked about previously. Now, the majority of the time you're going to use exit, and if you do use do not exit, it's very much like the exclude, where this takes priority and it takes a little more thinking about the logic if you use do not exit. So if you can afford to, use exit only. I mean, you could say do not exit if the object is warning or failed, meaning it will never, if it ever fails or warnings, it'll not exit during that time. And of course, you can contradict yourself, so be careful. That's why you gotta make sure you know what you're doing when you're using do not exit. So for the exit, for this specific use case, we're saying the loop number of attempts from this object equals 5, which you can adjust that number as needed. It's not dynamic, and you can't take variables or published data in there, but you could put a value in here, and then obviously anything you put there, like 5 times 2, will be 10 seconds, will be the entire duration of this loop attempt. It'll loop 5 times with a delay of 2 seconds, which equals about 10 seconds of total loop time. And that's exiting if no other criteria is met. Now we have OR statements, just like in the links. And in this case, we're doing link text, the actual line we're reading, contains hello, or line text from the read line contains HE. Now obviously these are very similar, since we have HE is contained in hello, so we could actually probably get rid of that one. So we're looking to see if it contains HE, and if it doesn't, it'll go into only for 5 attempts. And this is important, the number of attempts, because if you don't put it in there, it'll just loop indefinitely. And you want to make sure you have control of the number of times things loop. You may look at this and go, where did you find that? It's not right here. Well, if you click Show Common Published Data, you can see that it auto-selected the loop number of attempts that I had selected. But you could use total duration. I like to use number of attempts as my best practice, because then it's just simple math, the number of attempts times the delay between attempts. All right, you hit finish, and this object is set up for looping. But before we look at that, in a running workflow, we want to make sure that everything else looks good. So we're looking at this file, so let's go check to make sure that's there. It is. And we have dir ipconfig and ping opalis63, which do not say hello at all. So we'll be able to make changes to that file for the demonstration. And then for this demonstration, we're just looking at the first line, and if it contains the letters HE, and if it doesn't, it'll bail out after a certain number of attempts. Now, loops are nothing without the links that follow them, because most times with a loop on an object level, you're going to be looping until you meet some criteria, which is successful, or you're going to loop until you've tried as many times as you can and you fail. But in order, as you know from the complex link logic video, you need to define what success and failure are. So I'm going to open up the success link. And again, from a previous example, I'm just going to minimize this down to contains he. And then I believe, yep, I don't have any exclude. So my definition of success for this exit of this object is that it contains the letters HE. So I'm going to hit finish. And the fail criteria is that the number of loop attempts equals 5. And for the exclude statement, because if it happens to, on the 5th loop, contain HE or hello, and I'm going to change this to HE to be consistent, then we don't want it to go down both paths. So we gotta, with the exclude statement here, we definitely have to take into account the potential for it reading HE in the last loop instance. And then the objects here, we just have line text there, and then the failure will say loop attempts. Alright, I'm just going to check this in and run it, and we know in that file we do not have in the first line anything with HE. So I'm just going to let it go for the 10 seconds, and we'll see a new event in here, and it should be the failure event. You can see you won't see it here, but if you use the operator console, you'll be able to see the number of attempts, and I'll show you that in a little bit. So if we go to events, you see that it threw the error as expected. We put error there, and the number of loop attempts was 5. And if we do check the log history, you can see it looped 5 times and then produced the failure. Now I'm going to increase that loop time so I have a little more breathing room every 5 seconds. So now I have 5 times 5. I have 25 seconds total to change something in that file. So to get ready, I'm going to actually open it and get ready to save it. So I'm going to type hello in there, but I'm not going to save it yet. I'm going to click start, make sure it's running, see if we can get a loop out of it or not. I'll wait a couple seconds here. I go to here and hit save, and then within a loop or two it should, yep, it finished. If we take a look, it looped 3 times. I talked way more than I thought, and then went the send platform event route, which was the successful event. If I go to the events tab, we can see that it did say, I read the first line, which contained hello. All right, and of course, if I just started this up and with the first line being hello, it should finish immediately, and we should get another hello in the events because it didn't have to loop. Because on the exit was, if it contains hello, move out, don't loop again. So there didn't have to loop at all in that case. And that's it for object level looping. We're gonna revisit this on the trigger object, because that's one way to do policy level looping, is actually loop on the trigger object, because you're going to be triggering an object and then getting information back. Before we get to that specific use case for policy level looping, let's take a look at this policy level loop. Now this is a bit contrived, but I wanted to use this so you can see where we're kicking off a workflow. And you can see that we're passing some variables, computer and the line number. We're going to set the line number in the counter. We discussed counters previously. We're going to set that counter value. Then we're going to read the value that the counter is. So if the counter is at 1, it's going to read line 1. It's going to process line 1. And then it's going to send a platform event, increment, get the number of lines, compare it so it can stop, so it won't loop incessantly. And then once we decide whether or not we're continuing or not, we're going to trigger the policy. But the surprise for you may be we're going to trigger this policy. So we're looping back on itself, and then we're taking the counter value, which will, be set to whatever it is, maybe 2, read the second line, do the second command, give output, and then increase, and so on and so forth. So if we go back to that file, I think we were using this one since these are all commands. I'm going to delete that hello and make the dir the first thing in there. So essentially, this is one way to not only do policy level looping, but actually read the lines of a file that maybe contain execution commands, and then use those commands in the workflow, and only one at a time. So in the file, we can keep it open so we can take a look. First thing, we're going to do a dir, then an ipconfig, and then we're going to ping. And we're going to write each one of those to a send platform event. And in this case, the reason you would do this, if you were to do this, is because the second command depends on the first, and the third command depends on the second, which also depends on the first, and you could fail out at any time if you put any error handling in here and stuff like that. And then the thing that may or may not be confusing to you at this point is the compare values. So if the counter value, or the line we just read, is less than or equal to the total number of lines, then we'll continue. If not, we won't, and that happens in the link logic. We could see we only continue if the comparison that we talked about is true. And we'll run through this right now. We got to kick it off from the operator console. Alright, we're going to start this up. Computer, local host, and I want to start on line number 1. So what this is going to do, it's going to be already through this. It's going to be completed, yep. It's already on the next trigger. It's probably easier to see it in the log here. And it'll be on the third one right now. Unless it's already finished with those. Yep, it already did 3 quicker than I can get to it. So if we go to the events, you can see we have 3 pure output entries in here. The first is the dir, as we would expect. The second is the ipconfig. And the third is the ping. And it looped through each of those. If we take a look at the history, it went through and then, of course, increased the counter. The counter was set to 2. Then we go through, increased it to 3. We went through, increased it then to 4, and then when I did its comparison, 4 is greater than the total number of lines, which is 3, and it did not continue. It didn't trigger for the 4th line. So this is one of the first options for policy level looping, looping back on yourself. There are other ways and reasons you might want to loop back on yourself as far as the policy is concerned, but this is one of them. And this replaces, and if you're familiar with the older versions of Opalis, drawing circular graphs. So instead of looping back here to the beginning, let's say, drawing a circular graph like this for a loop, we have to actually trigger, because pipeline mode does not accept circular graphs like this. In fact, if we just drew this out so it's complete and we try to check it in, it'll yell at you saying it contains a cycle. A circular graph like this. It'll check in, but it will not work. So I'm going to check that back out and change this back. In essence, triggering itself results in that loop that previously in older versions you can draw as a cycle or a circular graph. But it's not necessary anymore. You just put a trigger policy, start at the beginning, go forward, start at the beginning, go forward. And remember, always add some check values in there so you don't cycle forever. Just like we did in object level looping, you want to make sure there's an exit plan. And of course there's an exit plan here with the compare values. Alright, I'm going to check that in. And then we're going to just go on to the next option for policy level looping. Alright, so this looks a bit different than the last one, where we have a trigger policy and of course success and failure routes, just like we did with object level looping, except this time the object we're triggering is the trigger policy, which underneath there's a policy there, which is here. And it's just doing something simple like run program, but we can have as many different statuses as you want to come out here. In fact, I was making some up when I did this previously. So we can have a success, and when you define what success is, whether in the links, failure, or maybe it's, something weird or something specific to your use case where the pure output contains hello, that's neither success or failure, that's something else entirely. And then by using the published policy data object, and of course, if you remember from the nested policies video, if you go to policy data, we have some pure output and status. And the status is an integer value that we're assigning it. So if we hop into these, status 1 is success, status 50 is weird, and status 99 is failure. Now, because you have the ability to create whatever status you want for whatever success, warning, failure, weird, or whatever you want to call it, you have lots of control over what the policy does and what it reports. So if we go back to the master policy, we can check out the success and failure links here. So for success, we're saying status, which is coming from the policy trigger policy object, that's the made up value that we did for this specific use case, equals 1, then we'll continue. And for the exclude statement, we had an example in here last time that the pure output from run program task contains fail.txt, which was probably part of a dir or something that I was doing. Now in the failure, status is equal to 1, or the opposite of the previous object actually contains fail and no exclude statement. So if we trigger this like we would, we're going to trigger dir, with the command of dir localhost on the local machine, and then we're going to do a dir on this directory, and I bet there's a fail in there. There is a fail in there from the last example. So we're just going to let this run, and we're going to loop. Let's check out the looping. There's 10-second delay between loops, a maximum of 10 loops, so that's 100 seconds it could possibly run for. And the exit criteria is status equals to 1, or pure output from run program contains the word continue. So those are the things that it's going to exit on. And do not exit, there is nothing. Alright, this is just like object level looping, except we're using the made up statuses and any other data that's coming from the child policy in the criteria for this example. So as I stated, we're going to run this as is with the fail.txt in there, and we're going to see what the results are. So I'm going to hit run here. It's going to trigger this guy. It's already triggered the sub policy. You can see it's working on it. Come back out here, and it's done with that one as well. So let's investigate what it's done, and we'll reverse engineer it from there. So it went down the failure path. So let's look at that criteria. Contains fail.txt, which it did, or the status was 1, or not equal to 1. Now let's take a look what actually was generated. We went down the success path here, even though the object spelled wrong. So we know that what was published was the number 1 for success and the pure output, but the pure output contained fail.exe, so when it came back out here, even though this one's looking for equals 1, we have an exclude statement for fail.txt in the results, and in here we had either does not equal 1 or contains fail.exe, so that's why we went down this path. Alright, easy enough. We'll go ahead and delete fail.txt and run this again. Alright, this time we should have slightly different results. So starting here, we still went down the success path, but this time it didn't contain fail.exe, so it should have gone down the success path as it did. I guess we could check out the events and see how that went. So even in the events, we could see that status was equal to 1, but because it contained fail.exe, it went down the fail. And in the success, it was just successful, and it didn't obviously contain fail.exe. So let's actually make this loop, since this is a looping instructions. And the reason it wasn't looping is because the looping criteria that we have set up here was met right off the bat. We need to make it fail or not meet that criteria. So if we take a look at the criteria, we're either looking for a status of 1, which in the child policy is success from the dir command. Pure output contains continue, or the number of attempts equal to 10. So we don't want it to go to 10 attempts, but we want it to loop a couple times. So I think I know how to do that. if we check out the trigger policy itself, it's looking for a directory called c:\demo loop test. So if we just modify loop test, and I'll just make it loop test 1, then it won't be able to do a dir on that directory because it doesn't exist. And then I'll change it after a couple cycles. We're going to start this up. All right, looks like it's running. You can see that it has gone down the failure route. So it's still running. And if we did check out operator console, we can see that it's looped twice so far because it went down the failure path twice. Now, if we go and change this to loop test, next time it tries, it will find success and we'll go out and pass the success path. Come back in here. It's now triggered 4 times. Now it finished with success as we would expect. So if we go into the events, we can see that it finally finished as we expected. But if we go to log history, and we saw that from the operator console, it triggered 4 times and then went down the success path. If we let it go for the entire 10 cycles, then it would come out here through the fail path, and we've seen a failure, what that looks like here, but with a status of 1. So for demonstration purposes, I'll let it run with the errors, and so we can see that. So I'm going to rename this back to 2, and then we'll kick this off again. And so I don't have to wait, and you don't have to wait. We'll change this delay to 2. So I'm going to start this up. You can see it's running. We go to the operator console again and wait for it to finish. It's taking a bit of time, so it's almost finished though. I should have really changed the number of attempts, not the duration, I guess. But we're nearing the end here. And there we go. I went down the failure route as expected, so we can go back into client, look at the events, and there we go. Status failure 99 because it went down this failure path 10 times. If we look at the log history, there we go. It was triggered 10 times, and the couple from before. And if we go back to here, we look at the log history here, it's exactly what we just saw, where it went down the failure path. So that's policy level looping, but with the object level looping turned on for trigger policy. And of course, if you do that, you need a sub policy. And you'll want to take advantage of the fact that you can create your own statuses based on your own criteria, even if they're weird. And you go from there. To recap, we did object level looping just on a regular old object. We did policy level looping by triggering policy itself at the end, so looping upon itself. And then we did policy level looping where we're using object level looping on the trigger policy object with a subroutine. And of course, you could have this same scenario over and over again. So this can be subroutine A that you're looping until a certain result. Then you can have another one, subroutine B, subroutine C, and so on down the line. It's completely up to you. I hope this wasn't too confusing. You do need a foundation of nested policies for the last example, but from the very beginning, these are very simple to set up. Even this one's very simple. You just have to get things configured properly. And then finally, this one, if you want to test yourself and your logic skills, you go ahead and work through this. But I hope this has been some help. I know this is a very complex topic, but once you grasp this, there's nothing you can't do with Opalis. We certainly appreciate you watching. Thank you.